Hello, this is Hui. Welcome to watch my video, C++ programming on Linux. In previous video, it has discussed basic Libusb device hot plug event notification feature. In this short video, it will continue exploring how to perform I/O communication with USB device. And the same as the previous video, we will use USB flash driver device as example device for exploring how to transfer data command between host and USB devices. As we know, USB flash drive is a kind of USB mass storage class device. The USB mass storage device class is a set of computing communication protocol that makes a USB device accessible to a host computing device and enable file transfer between the host and the USB device. Device connect to a computer where this standard include hard drive, CD or DVD, USB flash drive, and solid state drive. The example in this short video, we are going to write a C++ program, libusb test flash.cpp, to perform I/O communication between host and the USB mass storage class device. Here on our Ubuntu Linux, we start from copy previous video's example, libusb hotplug.cpp, but in order to better focus on I/O communication between host and the USB device only, we made a little adjustment. Instead of detect hot plug USB device, it will input VID and PID from command line as an argument, then display device parameters. Here is the previous video's example, libusb hot plug. And after USB device has been attached, program detect the USB, then display the parameters. For today's example, we start from copy this example but make a little adjustment. Instead of detecting hot plug device plug-in, we input device VID and PID from command line, then display the parameters. Now we start editor our example, libusb test flash.cpp. As we said, this program is the copy of previous video's example, but we made adjustment. Get VID and PID from command line. We declare the variable vendor ID and the product ID. After verified command line argument, first convert string to 2-byte assigned integer argument 1 to vendor ID, argument 2 to product ID. Then we initialize libusb, declare the device array and the device using libusb get device list to get all the USB devices. Make a loop for each device from the device array. If the vendor ID and the product ID match, we call this function print USB info pass parameter device. This function, we get a device descriptor and we get a configuration descriptor. Then we make a loop for each interface, find the number of outer setting, and we make a second loop for each outer setting, find the number of endpoint, and the third loop for each endpoint, find the parameter of attribute endpoint address. Also verify the endpoint direction, which is endpoint in or endpoint out. At this moment, we find the device endpoint in and the endpoint out, so we call the function test mass storage. The function test mass storage perform I/O communication between USB devices and the host. So first we test if this device is able to open. If Libusb open success, it means our device is accessible. Then we can start to perform I/O communications. This is the stop point of previous video's example. Now we start forward to perform I/O communication between the host and the USB devices. To perform USB I/O communication, first step is a claiming interface. Function Libusb claim interface claim an interface on a given device handles. You must claim the interface you wish to use before you can perform I/O on any of its endpoints. If auto detach kernel driver is set to 1, it means enable for device. The kernel device will be detached if necessary. To enable kernel driver auto setting using the function libusb set auto detach kernel drive. Function libusb set auto detach kernel driver enable or disable Libusb's automatic kernel driver detachment. When it is enabled, Libusb will automatically detach the kernel driver on an interface when claiming the interface and attach it when release the interface. Back to our editor. Step 1, RC. First parameter is device handle. The enable 1. First parameter is second parameter is interface. Copy for line for YY. Paste here. If not a success, we print the information. If not a success, print the message. Libusb claim interface error. Next step is going to check if a kernel driver active from an interface. If active, then call function libusb detach kernel drive. Function libusb kernel driver active determine if a kernel driver is active on interface. If a kernel driver is active, you cannot claim the interface and the Libusb will be unable to perform I/O. So if active, we need to call function libusb detach kernel driver to deactivate this. Libusb detach kernel driver, detach a kernel driver from an interface. If successful, you will be able to claim the interface and perform I/O. This function needs parameters handle and interface numbers. For function libusb kernel driver active, the return code 0 if no kernel driver is active, 1 if a kernel driver is active, other is error. Back to our editor. First parameter is the handle. Second parameter is the interface. If RC equal 1, it means active. Else, if RC not equal 0, means the error. We print a message, a kernel driver active from interface. Copy this for line for YY. Return code is not a success. Print a message. We're not able to perform I/O, so we return. If RC not equal 0, it means error. Copy this two line to YY. Paste here. Print the message. Error Libusb kernel driver active check. Now we are ready to communicate between USB and the host. First, we're going to get max LUN logic unit number from the USB device 1 byte from 0 to 15. LUN function is specified in the documentation Universal Serial Bus Mass Storage class Buck-only transport. The LUN stands for the logic unit number. The device may implement several logical units that share common device characters. The get max LUN device request is used to determine the number of logical units supported by the device. Logical unit number on the device shall be continuously starting from LUN 0 and max to the 15. Here is the parameter when we issue control request to the device, and this is the value for the parameter. The device shall return 1 byte of data that contains the maximum LUN supported by the device. If no LUN is associated with the device, the value returned will be 0. So we make a copy of this line. We back to our editor, paste here. First, declare a variable, 1 byte, name LUN. To send a request, get max LUN, we need to use Libusb control transfer functions. Libusb control transfer perform a USB control transfer. It takes 8 parameters: handle, request type, request value, index, date, and data length. Last one is the timeout. This function, on success, it will return the byte actually transferred. Back to our editor. First parameter is the handle. Second parameter is the request type, will be the class, interface, and the device to host. It means endpoint in. Class, interface, endpoint in, request field 254 FEH. Next is the value will be set to 0. Interface field set to the interface number. Next is the pointer of date. Length field is set to 1, and the timeout. If error pipe, it means not supported. We set LUN equal 0. Return code less than 0, it means error. Copy this 2 line to YY. If a success, print read max LUN. For operating on a mass storage device, SCSI is a command used communication protocol or command with storage devices, for example disk or CD. SCSI command can handle all kinds of disk operation like format disk, write date, read data from disk. In this short video, we'll focus on how to send the communication between USB device and the host. So we just send 2 commands to the device, the inquiry command and the SCSI request sense command. Here is the inquiry command introduction. The inquiry command requests that information regarding the logical unit and the SCSI target device to be sent to the application client. The inquiry command, the first byte is 012, is operation code, and the first byte is allocation length. So the standard inquiry date shall contain at least 36 bytes, so inquiry length will be the 36. Back to our editor. To send inquiry command, we need 4 steps. Prepare command, send command to USB flash drive, request inquiry command date from the flash drive. Then check SCSI command status. So the first step, prepare command. First, declare 16-byte CDB command descriptor block. Date buffer 252. Structure command block wrapper. Command status wrapper will return the status of command sent to the device. Command block wrapper and the command status wrapper is defined in our header file. Here is the structure command block wrapper and the command status wrapper. It's defined in the document USB mass storage. Here is the specification of a command block wrapper. Here is all the definition. The byte 0 to 3 is the signature. The byte 4 to 7 is the tag. Byte 8 to 11 is the date transfer length, flag, and LUN, which means the logical unit number, command length, and SCSI command. It's total 31 byte. And here is the command status wrapper CSW definition. It's total exactly 13 byte. 03 is the signature. The tag will be the echo of CDW, the date result, and status. SCSI command descriptor block will be the 6, 10, 12, or 16 byte. It is specified in the SCSI document. Here is the SCSI command descriptor block specification. And for the fixed length SCSI CBD format, it will be 6 byte command, 10 byte command, 12 byte command, and 16 byte command. So here we defined CDB with 16 byte. Here's the inquiry command specification. Byte 0 will be the 0x12 for the operation code, and byte 4 will be the allocation length, at least 36 byte. So back to our editor. Next, set CBW. CBW signature is specified in the document. The signature field shall contain the value 43425355H, later adding 0x55. Declare a tag, set the initial with 1, so each time we send the command tag plus 1, data transfer length, inquiry length 36 byte, data return from endpoint in, command length going to 16, and memory copy command CDB to CBW. Now we have prepared sending SCSI command. Next step, we're going to send command using lab USB bulk transfer. declare variable, transfer the byte. First parameter is the handle. Second parameter is the endpoint. Endpoint out. CBW, command block wrapper, be 31 byte. Transfer the byte. Next is the timeout. If the error pipe, we are going to clear the halt, then retry again. First parameter is the handle. Second parameter is endpoint. Retry again. If return code is not a success, print a message. Send inquiry command error. If success, sending inquiry command. And the total bytes we send to the device. After sending inquiry command, we are going to read inquiry command date. Declare variable, receive the bytes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Copy this 10 line, 10 YY. Paste here. And received from endpoint in. Date will be right into the buffer. Size, inquiry length, receive the byte, and the timeout. If error pipe, clear the halt, and we receive again. Print a message, error receiving SCSI inquiry command, date, success. Received bytes. Right now, we send inquiry command and received date successfully. Number of byte received is RCVD byte and the date into the buffer. Here is the specification of inquiry date. In this short video, we are not going to parse the date. We just print this date. Function display buffer HEX, first parameter address of buffer. Second parameter is byte. Last step will be the check the command status. Memory set CSW. Command status wrapper. Transfer the byte equals 0. We copy 5 line. In order to save typing, we just copy paste. Date will be CSW size. If error, we clean the halt and try again. If success, print the message. Print out the status check. Now we completed send the inquiry command, get the inquiry command date, check the inquiry command status. Next, we're going to send the request since command. Here is the request since command specification. The request since command requires that the device server transfer sense date to the application client. The operation code 03, allocation length. The device server shall return at least 18 bytes of parameter date in response to the request sense command. So the allocation length shall be the 18 byte. Back to our editor. First, prepare the command. Copy this 25 line, 25 YY. Paste here. Request sense operation code 03. query length, request sends length 18 byte, signature no change, target +11, CDB command is 16 byte, no change. Step 2, send request sends command to the flash drive. So we copy this 12 line, 12 YY, paste here, actual transfer byte 0. If error, print a message, request sends command error, success. Read request sends command date, top. Copy this 13 line, 13 YY. Request sends length. If error, print a message. Request sends command date, error, success. The last step, check SCSI command status. Copy this 8 line, 8 YY. We paste here. Then we finish our program. We save this. We compile our program. Now program has been compiled. Here is our program. We compiled list device program to super user. First we list our device. Here is our device. We test our example. First argument is VID. Second argument is the PID. Now you can see we get a VID, PID from command line. We got a parameter of these USB devices, and then we start perform I/O between USB devices. First, we get max LUN logical unique number, which is 0. Then we send SCSI inquiry command to device. Total byte sent 31 byte. Inquiry command successfully received 36 byte. This is all the data we received, 36 byte. Check the command status is success. We send the second command, request sends to device, 31 byte. Received 18 byte successfully. Here is the 18 byte we received, and the status check success. Now we have a successfully send and the receiving date between host and the USB devices. Hello, this is Hui. Thanks for watching my video. Wish it is useful, and it's going to be great to have your feedback.